Hey guys, so today we're going to start chapter 3, which is dedicated to the electron. So really this is a continuation of chapter 2. In chapter 2 we discussed the basic structure of an atom, but we dedicated most of our time to nuclear structure, particularly the protons and the neutrons of an atom. So if we think back to the biggest experiment and the biggest idea that helped us develop nuclear structure, we think back to Rutherford's gold foil experiment. So Rutherford's gold foil experiment helped prove that atoms are mostly empty space. Okay, so we have a dense area with positive charge that we call the nucleus. So if we think about Rutherford's model of the atom, we have this tightly packed nucleus, and then we have some electrons. Okay? In his model, the electrons are just orbiting the nucleus. So if I draw that to represent the bigger atom, we just have electrons out here. And they're all orbiting the nucleus. But that model was really incomplete. Okay? There was no way to give us a clear picture or a clear idea of where the electrons actually are, or a quantitative way to describe where the electrons are. So his model was great in that it told us that atoms are in fact mostly empty space, and we do have the nucleus, but there was still a lot of work to be done on electrons and their configuration in an atom. So most of the work after Rutherford dealt with the idea that atoms can absorb and emit light. So when an atom absorbs light, let's just say we have an electron, this right here. Okay, and I'm not drawing a clear defined boundary for this atom because atoms really don't have clear defined boundaries. So we will have a nucleus and just one electron. We'll just show this one for reference. So if light is absorbed, so I'll just show this little lightning bolt looking thing to show that light is absorbed, the electron would move further away from the nucleus to show that it's higher in energy. Okay, so the higher in energy an electron is, the further away from the nucleus it is. So then, let's say that the atom emits the light back out, so it releases that energy. At this point, the electron would move back closer to the nucleus. Okay, so it's going back lower in energy. So scientists discovered that atoms can absorb and emit light. So light is a form of energy, so they absorb and emit energy. So when they absorb energy, electrons move to a higher energy state, which is further away from the nucleus. When they emit light or energy, they move closer to the nucleus, move to a lower energy state. So using this idea, scientists knew that electrons weren't locked in a position. They could move to areas of higher and lower energy. Okay, so this idea still kind of fit with Rutherford's model. He said that the electrons are just kind of floating around out here. They're orbiting, so that would make sense that they can move from an area of higher energy to an area of lower energy. However, with this type of model, this would suggest that all atoms are extremely unstable, okay, when in fact most atoms are in fact very stable. So let's kind of explain why this model would predict that all atoms are very unstable. So let's just think about, we have the nucleus again. So let's think about we have an electron. Okay, we'll just visualize a single electron here. And let's just say that it is orbiting around the nucleus. Okay, so we'll just draw a little arrow showing that it's orbiting. So as the electric particle moves around, it has to lose energy. Okay, it can't maintain the same amount of energy forever if it's not being held in place by anything. If it's just kind of randomly moving around this this nucleus, it would slowly lose energy. So as it lost energy, it would be pulled in closer to the nucleus. Okay? So as it gets closer to the nucleus, it would continue to speed up because the nucleus is attracting the electron, because we know that the nucleus has a positive charge because of the protons, and electrons have a negative charge. So positive and negative charges are attracted to each other. So based on this model, the electron would slowly get closer and closer, and it would speed up, and eventually the atom would collapse. Okay, the electron would collapse into the nucleus, and really who knows what would happen. So we knew that likely didn't happen because we saw that atoms were fairly stable. And if they're stable, we have to have some other model to explain, what's really going on here. So then Niels Bohr comes along. So Niels Bohr set out to propose a model for electron configuration to try and explain why Rutherford's model wasn't complete in relation to electron configuration. And he did this by exploring the absorption and emission of light with electrons and atoms. So if we think about this theory, we first have to consider one new big idea. So electrons are very similar to light. Okay. So there is this idea about light that we have, and you may have or may not have ever heard of it, and it is called wave/particle duality. Okay. So that means that light kind of behaves as a wave, and it kind of also behaves as a particle. So to call light just a wave is incorrect, and to call light just a particle is incorrect. So electrons are the same way. Electrons cannot be described as a wave or cannot be described as a particle. They have to be described kind of as both. They have characteristics of both. So this is kind of a big jump if you think about the three basic building blocks of atoms: protons, neutrons, and electrons. Protons are particles. Neutrons are particles. That's pretty much it. That's all there is to them. But electrons are much more complex here. So before we really dive in to Bohr's ideas and the Bohr model of an atom, first let's kind of take a step back and look at the wave description of light. So what characteristics of a wave does light have? And then the particle description of light. Those ideas are typically easier to understand, and they can be relayed very easily to electrons as we move forward. Okay, so this was just kind of some background information before we dive in. At this point, really the only two things I need you to be comfortable with are the ideas that electrons and light both behave as waves and particles at the same time, and that atoms can absorb and emit light or energy, and when they absorb light, electrons move to a higher energy location. So higher in energy is further away from the nucleus. So you might want to write all that down. And when they emit light, they move to a lower energy location, so they move closer to the nucleus. Okay, so we'll stop this video right here. We'll pick up in the next videos talking about light and its two different descriptions. And then ultimately in this chapter, what we want to do is to be able to explain the configuration of electrons. So explain exactly in an atom where an electron is located at.